Let's see, what else can I do? I think that I'm going to try playing with number here. So what all can you do with some of these numbers? I'm going to erase this. This was all just for testing. So let's have a number equal 22. So I'm going to print this out just to be sure, because, you know, I'm paranoid. Sys out, control space, number. Indeed, that works. So now what I like trying to do is, can I multiply this by, let's say, 4? So I don't say int again. I actually use the same thing again, the same name, number. Because if I tried to use int again, it would try and create a new thing called number, and Java would throw a fit on that. So what I'm going to say is number equals number times 4. This is the asterisk. It's on the 8 or on the keypad, and that stands for times. So what happens here is the number, whatever's inside of it, gets multiplied by 4, and the answer to this whole thing gets assigned back into number. So if I print this out, and run it, 22, then 88. So computers can actually execute all of the basic operations, plus, minus, times, divide, and there's a system of mathematics libraries that allow you to do a lot more as well, logarithms and all that. Now, something that you should also note is, let's take this 88 here and say number equals number divided by 10. You might ask yourself, well, what is the answer to that? What Java thinks it is this. 8. And you may be thinking, wait, where did the extra 1's digit go? When you're doing division using integers, it always truncates the number. It just tosses the decimal away. It doesn't round it, it actually gets rid of it. That's something to watch out for. So whenever you have this being an integer and this is an integer, it uses integer division, which truncates the number. Now if you have a more precise number, so let's say this is 10.0. By putting this decimal number in, this makes this whole thing a decimal. So since a decimal is a more precise number than an int, notice it's throwing an error here. It actually converts them both to doubles. So this is actually a double. It's a decimal number. This is an int. What it does is it converts this number here, this int, to a double automatically and makes this whole answer a double. And then when I try and take this whole double and put it into an int, it's like, no, you can't do that. It's a more precise number. If you have a double on the right side and you want to put it into an int, you have to do something called casting. So what I do is I take this whole value and put it in parentheses. And before it, I put a set of parentheses and say what kind of thing I'm trying to make it into. So then I can say, that whole thing there, that's actually an int. So now it's happy with that. So you can do that with the various number types. What about a character? So what happens if I want to make a character into that? So what I'm going to do is I'm going to say char letter equals maybe a capital B. And what I want to try doing is I want to take a number and make it equal to a letter. Chars are actually secretly an encoding of numbers that match into characters. So if I actually print this out, it says 66. What? How on earth does capital B become 66? How does that even happen? It turns out there's a special encoding called the ASCII chart that we need to look at to figure that out. So I have a copy of it here. You can Google this and you'll find it pretty quickly. So I said a capital B. So we're looking at the things in red, 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 red. There's a capital B. hey, that's number 66. Whenever you have something on the keyboard, a symbol or something that you're typing, there's a chart like this that actually shows you all of the different characters. A lowercase b is number 98. A capital B is 66. This asterisk symbol is 42. So this ASCII chart is common across all computers. Java actually has an extended set, so it's called Unicode, which actually has symbols like Chinese characters. I believe it has Klingon in it, all sorts of stuff. Whenever we're actually taking a character and making it into a number, it actually looks up in this ASCII chart what it is and makes it into the decimal number. So a weird thing about this is if I take the character 1 and assign it into an int, I get the number 49 back out because that's the character symbol for it. The ASCII chart is pretty old, so if you look at some of these things, especially at the beginning, a lot of these don't really apply anymore. For example, number 7 is a bell. So typewriters, it used to be when you got to the end of the line, there would be a bell that would ring to let you know you got to the end of the line. So these are all various things that you can do with variables as far as assigning them different values. In JRU, we had ways of checking to see if something was true. So we had if statements and else statements, while loops. All those things still work in Java as well. We don't have things like isFlower, because there is no flower here, but we can do tests nonetheless using numbers and letters. So for example, let's go ahead and have a test. So that was a Boolean test equals true. Just like before, we can use an if statement, has 2 parentheses around it, and we'll put our test thing in here. We have a line of code that is going to be executed if it's true. So I'm just going to put a system out print line, this is true. And why don't I put in an else statement which says, this is false. So what goes inside of here? If we're comparing 2 different things, like 2 different variables or 2 different numbers, there's a few things we can do. So for example, test, we can check to see if test is true or check to see if it's false. What you do to see if it's true or false is you actually use 2 equal signs and then the value you want to check against. So if I run this, it says this is true because test is true. I assigned it that value here, and it goes inside of there. So the reason that we have 2 equal signs inside of here is we're not taking the value of true and putting it into test like we have in this line here. We're going, is this thing the same as this thing over here? And it requires 2 equal signs. Watch out for that. So if you're ever doing an if statement or a while statement or anything like that, make sure you use 2 equal signs. It's a very common mistake. So what if I say false up here? True and false are constants that are special words. So if I run this, this is false. This part isn't true, so it goes to the else statement, prints this out. Now if we're using numbers, so I'm going to make this an int number 15. So I can use the 2 equal signs with ints to say number equals 15. So you can test equality inside of an if statement again using 2 equal signs. So if I run this, number equals 15, this is true. Now I can also say less than and greater than as well. So let's make this number 20 and say number is less than 15. Number is not less than 15, so it goes down here. If I change this to a greater than sign, this is true because number is 20, which is greater than 15. This is true, so it goes up here. Much like with JRU statements, you can use and or statements. So I could say number is greater than 15 and number is less than 40. I run this, this is true. If I make this 45, this is false. I make this 2. This is false because it was outside the range. And likewise, you can use OR statements if you want to as well. So what else can I do? Let's try using a while statement. How about while number is less than 5? Inside of here, what I'm going to do is I'm going to say system.out.println number. So I'm going to print that out. And what happens if I run this? Uh-oh. It's 2, it's 2, it's 2. It's going on forever. Let me stop that. That little red stop sign thing will actually terminate it. This is something called an infinite loop, and this often happens while coding if you do make a mistake. So the problem is that number is always less than 5, so it's never going to leave this while loop. It will continue printing out number forever and ever and ever, or until there's a power outage. So we need to make sure that somehow we get out of here so that we get to the end of our program. So what I'm going to do here is, let's do number equals number plus 1. So I run this, 2, 3, 4. Once it becomes 5, it is no longer less than 5. It's actually equal to. So then it stops running this, gets out of the program, and ends. By the way, besides less than and greater than, you can also say less than or equal to, or greater than or equal to. And actually, you can even say not equal to. This means the exclamation point is not, just like it was in JRU, and not equal is a valid thing. All right, so those are the basics of Java programming.